Hi students, welcome to another mathematics session. This is Elim Kiganjani. If it is your first time to be here, consider subscribing to the channel so that you are going to be updated in the coming contents. So today we are going to go to double angle formulas. We continue with coverage of trigonometry, a topic of Form 5 mathematics. So with double angle formula are trigonometric identities which express trigonometric functions of 2 theta in terms of trigonometric functions of theta. They are special cases of compound angle formula. So you remember we had discussion on compound angle formulas, and with compound angle formulas, we derived the formulas for cosine, sine, as well as tangent. So for we to be able to get the identity corresponding to cosine 2 theta, I'll consider cosine A plus B. With cosine A plus B, we are going to consider a case now when A equals to B equals to theta. How will be the expression? So first of all, remember cosine A plus B, it was cosine A cosine B minus sine A sine B. Now we are going to be having a case now where A equals to B equals to theta, so that you'll be having cosine 2 theta, and cosine 2 theta will be cosine theta minus sine theta sine theta. So cosine 2 theta will be cos squared theta minus sine squared theta. So this is the first expression we will be having corresponding to double angle formula of cosine. Now this formula can be modified further to have different expressions, and we are going to refer to this identity sine squared theta plus cos squared theta equals to 1. So from this expression you can make x the subject, you can make actually sine square the subject. If I do that, sine square theta will be 1 minus cos squared theta, and so I can substitute here back, so that we'll be having now cosine 2 theta will be cos squared theta minus, in the bracket, 1 minus cos squared theta. When you open the bracket, you'll be having cos squared theta again, plus cos squared theta again, minus 1. When you simplify further, we'll be having 2 cos squared theta minus 1. So this is another expression corresponding to cosine 2 theta. So that is another expression corresponding to cosine 2 theta, and that is 2 cos squared theta minus 1. Now what happened when I'm going to substitute cos squared theta with sine squared theta? Remember, again, cos squared theta, this is 1 minus sine squared theta. And so when I go back to this expression, cosine 2 theta will be 2 in the bracket, 1 minus sine squared theta minus 1. This is going to be equal to 2 minus 2 sine squared theta minus 1. 2 minus 1 is going to be 1. We have 1 minus 2 sine squared theta. So to make it clear, so cosine 2 theta will be 1 minus 2 sine squared theta. So that is another double angle formula corresponding to cosine 2 theta. So cosine 2 theta can be expressed actually in three different forms. The first form is cos square theta minus sine square theta. The second one is cos 2 theta equals to 2 cos square theta minus 1. And the third form is 1 minus 2 sine square theta equals to 0, dear students. We are going to jump to sine 2 theta, and later on we are going to generalize. So with sine 2 theta, how will be the expression? Again, we are going to refer back to sine of A plus B, which will be actually sine A cosine B plus sine B cosine A. Now what happened when A equals to B and equals to theta? So that is the case when we have special case, sine 2 theta will be equal to, we'll be having sine theta cosine theta plus sine theta again cosine theta, which will be equal to 2 sine theta cosine theta. So to make it short, a double angle formula corresponding to 2 theta is going to be equal to 2 sine squared theta cos squared theta. So that is the formula corresponding to sine, double angle formula for sine. The last one, dear students, is tan 2 theta. So with this, what will be the expression? Tan 2 theta, I think we have to start again from tan A plus tan B. And you remember tan A plus tan B, this is actually tan A plus tan B divided by 1 minus tan A multiplied by tan B. And coming to special case now, when A equals to B equals to theta, coming back to the same expression, we'll be having tan 2 theta now equals to tan theta plus tan theta again divided by 1 minus tan theta, which is going to be equal to 2 tan theta over 1 minus tan squared theta. So the last expression for tan 2 theta, this is going to be equal to 2 tan theta over 1 minus tan squared theta, dear students. So that is the double angle formula corresponding to tan 2 theta. So we have already derived the three formulas. The first one was for cosine, the second one was for sine, and the third one was for tan. Now, I want to give you a very general expression, general overview of these double angle formulas. So I'll be saying that generally, an apology for my rough notes. So I'll be saying that generally, if we'll be having cosine 2n theta, this is going to be equal to cos squared n theta minus sine squared n theta. And this is the case when n equals to 1, 2, 3, 4, and so forth. Okay. Again, this can be rewritten again having 2 cos squared n theta minus 1 or this can be rewritten as 1 minus 2 sine squared n theta. It's important actually to note this important generalization. It's important to note this general uh, way of expressing the double angle formulas. What about sine? Having sine 2n theta, sine 2n theta uh, will be having again 2 sine n theta cosine n theta, dear students. And that is the general way of expressing the double angle formula for sine. And the last one is tan. So having tan 2n theta, this is going to be equal to 2 tan n theta divided by 1 minus tan squared n theta, and this is going to be the general picture of double angle formula corresponding to tan, dear students. So after all these abstract informations, derivations, and so forth, let us dive into some questions. So the first equation, express sine 3 theta in terms of sine theta. So first of all, okay, we'll be saying solution. So sine 3 theta, we can express it as sine 2 theta plus theta, so that you'll be having this is equal to sine 2 theta sine 2 theta cosine theta plus cosine 2 theta sine theta. We know sine 2 theta, that sine 2 theta will be 2 sine theta cosine theta multiplied by cosine theta again, plus you'll be having cos 2 theta, you'll be having actually I'll prefer to use 1 minus 2 sine squared theta times sine theta. Mind you, the question asked you to express it in terms of sine theta. So this is going to be equal to, you have 2 sine theta cos squared theta plus sine theta, you open the bracket, minus 2 sine cubic theta. You're going to deal with cos squared theta, and that is going to be 2 sine theta in the bracket, 1 minus sine squared theta again, plus sine theta minus 2 sine cubic theta. To proceed further, we'll be having expression actually 2 sine theta minus 2 sine cubic theta plus sine theta minus 2 sine cubic theta. You combine now like terms, you'll be having actually 3 sine theta minus 4 sine cubic theta. So that is actually sine 3 theta, dear students. That is the expression corresponding to sine 3 theta expressed in terms of sine theta. The second question, And this will be the last question for our today's session. Later on, we're going to solve some other questions. But as you can see, the question here is the question is demanding you to express uh, cosine 3 theta in terms of cosine theta. So as we can see the question, we are going to start with, so we have cosine 3 theta. Cosine 3 theta, this is cosine 2 theta plus theta. And by expanding now, we'll be having cosine 2 theta cosine theta minus sine 2 theta sine theta. And because we are going to express this in terms of cosine, I'll be just plug the expression corresponding to cosine 2 theta directly here, which is actually 2 cos square theta minus 1 multiplied by cosine theta minus, you have 2 sine theta cosine theta cosine theta. You open the bracket, you'll be having 2 cos cubic theta minus cos theta minus 2 sine, there is a problem here, sorry. So it was 2 sine theta cos theta times sine theta. So we'll be having 2 sine squared theta, then multiply by cosine theta. But we know that sine square theta, of course, sine square theta is 1 minus cos squared theta. So we'll be going to having this expression 2 cos cubic theta minus cos theta minus 2 cos theta multiplied by 1 minus cos square, 1 minus cos square theta, 1 minus cos squared theta. We proceed further, we'll be having 2 cos cubic theta minus cosine theta minus 2 cosine theta plus 2 cos cubic theta. You're going to combine like terms. Combining like terms, you'll be having 4 cos cubic theta minus 3 cos theta. This is equal to cosine 3 theta, yes students. So we have cosine 3 theta and we have also sine 3 theta. I'm going to attempt actually the way we can somehow express tan 3 theta. So I'll say, what about tan 3 theta from the two expressions we have? So tan 3 theta, this is sine 3 theta divided by cosine 3 theta. If I have to use these two expressions, am I going to get something? 3 sine theta. So this is 3 sine theta minus 4 sine cubic theta divided by 4 cos cubic theta, then k minus 3 cos theta. So with this expression, you can find a way to manipulate it so that later on we are going to have actually expression which is somehow promising. I will not prefer to this expression, but what about expressing tan 3 theta in terms of tan theta? It means I'll be saying that this is actually tan 2 theta plus theta. So this is tan 2 theta plus theta, and you'll be having now tan 2 theta plus tan theta divided by 1 minus tan 2 theta tan theta. To proceed with this, we'll be having uh, tan 2 theta, it is 2 tan theta over 1 minus tan square theta plus tan theta again, of course, over overall denominator, which is 1 minus, you have 2 tan theta multiplied by tan theta again divided by 1 minus tan squared theta. So with this expression in our hand, it's just the matter of simplification. And by simplifying, let us see what we are going to get. This is going to be equal to 2 tan theta plus tan theta within the bracket 1 minus tan square theta. Denominator 1 minus tan square theta is going to be common, so I'm going to ignore it because later on it's going to be cancelled with the other denominator in the denominator part, over 1 minus tan squared theta minus 2 tan squared theta. So as you can see, the expression we have here, this will be actually 2 tan theta plus tan theta will be 3 tan theta, then minus tan cubic theta divided by 1 minus 3 tan squared theta. So as you have seen, this is actually the expression for tan 3 theta. So that is tan 3 theta. Actually, this is the expression which is open for verification. You can do yourself, of course, and see if you're going to come to the same expression. So that is all actually regarding double angle formulas. We are going to do some other more questions in the other coming sessions. As I said, if it is your first time to be here, don't forget to subscribe and actually share with your friends so that we are going to spread the effect of mathematics. Until next time, dear students, I wish you all the best in your whole day. Continue learning mathematics. Peace.